Good morning, everyone. My name is Karol, and I'm currently a PhD student researching orthopedic implants in UCL. Today, I'll be introducing an area of research conducted by Dr. Daniil Nikitichev on custom 3D printing technology for medical phantom fabrication. So very briefly, I'll be taking you through what medical phantoms are, why we need them, as well as the advantages of using 3D printing for this, and then what we aim to achieve through our work, and an example of the fabrication of a kidney phantom. I'll then pass the floor on to Dr. Nikitichev, who will further detail the printer's capabilities. So what are medical phantoms and why do we need them? Essentially, phantoms are objects specially made to mimic anatomic or organ properties, in this case, in an imaging system. And they're important for clinical and surgical training, increasing the practitioner skills without the need for an animal cadaveric specimen, while also reducing the costs. Moreover, patient-specific phantoms, where the anatomical structures are patient-matched, we can imagine how they would provide surgeons with the benefit of understanding the complex 3D structures more and aid the preoperative planning to improve surgical outcomes. So let me just get this video running. A little demonstration of the 3D printer. And 3D printing enables us to create rapid, accurate prototypes based off of patient data acquired, for example, through the means of a CT scan. We're also able to create precise models matching smaller realistic structures, as well as easily manipulate the models for complex cases. With 3D printing, we are also able to adjust the physical imaging properties to further match the tissue. And there's also the possibility to take advantage of dual extrusion systems, which will allow us to accurately print and place two different types of tissue, so two different types of material, for example, for embedding cancerous tissue within the phantom. The material we are using for this is called gel wax, and it's an oil-based material. On top of being inexpensive and ideal for fused deposition modeling, which is the printing process that the 3D printer uses. It's also been shown in recent studies to be a suitable ultrasound and photoacoustic tissue mimicking material, whose properties can be easily adjusted by varying the concentrations of additives such as adding glass microspheres or titanium oxide. For example, this could be useful for helping PCNL surgery, which is a keyhole surgery used to remove kidney stones. Using ultrasound and guide wires to reach the kidney stones is a complicated process, and this could be made harder by having complex patient anatomy and stone physiology. So we've made a kidney phantom. So overall, the dream is to be able to create these scans quickly and efficiently for clinical settings by scanning, segmenting, printing, and then fully delivering the patient-specific model for the application. The first step after acquiring the DICOM image data from the patient is to segment the kidney and its internal calyx structures. We did this using freely available software, Seg3D, and then converted the 3D anatomy into a printable STL file, which we processed to remove any reconstruction errors. The kidney was split in half to improve its printability. So to print, the file was sent to a 3D printer, which then builds the model by depositing the gel wax layer by layer. The extrusion is then controlled thermally very carefully throughout the process to ensure that it's printed accurately. So once the two halves are printed in about under 20 hours, we get the final full kidney phantom, which upon visual inspection, we can see on the right, manages to replicate the internal kidney structure quite accurately. We've also embedded this within, we've also embedded a sort of cancer tissue mimicking gel wax into the phantom and imaged it underneath a photoacoustic imaging system to demonstrate the viability of using this technique for imaging system validation. As we can see, for 0.1% concentrations of titanium oxide, we begin to see that we get a response as we see in red. Overall, we've demonstrated the use of a custom 3D printing technology in medical phantom fabrication by developing a novel patient-specific photoacoustic kidney phantom. Further improvements in the future in this technique will take us towards more comprehensive and realistic kidney phantoms. So thank you very much for listening, and I will pass the floor to Dr. Daniil Nikitichev.